Good afternoon, everyone. So our topic is the implementation of level and virtualization, and our guest is the Jagjeevan Kashil. So they will be explain and about the our section about the implementation and level of virtualization.
So yeah, today we are diving into the topic that sits right at the heart of the modern cloud computing and system design and the implementation level of virtualization. Now, virtualization sounds like one of the big technical word for the people. Used when talking, it is used when talking about the servers, cloud platforms, and data centers. But underneath the complexity, the idea is actually very practical. And how do we make one physical machine behave like many separate machines? And to answer that, we are going to break that into the three major parts: CPU virtualization, memory virtualization, and IO virtualization.
Exactly. And what makes this topic interesting in the virtualization is not just the software tools. It is a combination of hardware support, hypervisor design, careful resource management. And so today we are going to discuss it in the way that's easy to understand but still technically deep through to the useful.
So yeah, also keeping this to grounded in real system behaviors, there are we are not just asking what is virtualization. We are asking what is implementation of CPU levels, how memory is shared and isolated among the processes, and how are the devices like this and network are virtualized.
By the end of this topic, we have the multiple topics in the podcast. So next one is the what is the implementation levels in virtualization?
Okay, let's begin with the foundation. The implementation of the level virtualization refers to the mechanism by which a hypervisor or a virtual machine monitors or creates the illusion of a full machine for each page operating the system on cloud. So it does not differentiate hardware, bare metal, and the virtual machine. So each gets thing like they have got their own processor, memory, storage, and devices. But in reality, all of them are sharing the same physical material. So you get the feel of using the physical material, but you are in background you are sharing that with others.
The keyword is here, this is the illusion, but it is a very carefully managed illusion. The hypervisor must ensure their three things like isolation, efficiency, and transparency. So, what is our opinion of it?
So, and the implementation challenge is different as resources behave differently according to their needs. CPU is about the only execution and scheduling. Memory is about the address transmission and protection. IO is about the device and interruption and data transfer. So we take a look each carefully.
So, our the next topic is the CPU virtualization. So, let's start with the CPU because that is the very the virtual machines appears to run and multiple people are used. So, at the CPU level, virtualization means a server is operating systems or virtual machines can share the some physical processes. So, each believe has the control over the complete CPU.
I think instead of topic, you can say this segment is very interesting in the cloud computing. CPU is a very virtualized one to the virtual machines. So there is a vCPU term very popular in cloud computing. Yeah, is what the gauge OS sees, and they does not get the original CPU fully. So hypervisor schedules the vCPU into the real CPU cores. That scheduling is one of the most important parts of the CPU virtualization. If the system has, for example, 8 logical cores, then and 12 virtual and 12 virtual machine, the hypervisor decides how much each VM gets the core and in their part of the CPU and how much they can run.
So in older system that was the difficult because the guest OS could execute the privilege and instruction that only the real hardware should allow. That creates a major problem. So how do you let the guest team it is the control without actually giving the full control?
Yeah, you are absolutely right. If the guest tries to execute the privileged instruction, the CPU would tap that into between the hypervisor step. The hypervisor would then emulate the effect safely and try to mitigate the situation. For example, let's say if a guest OS has to modify the protected control register, the hypervisor will intercept it and perform the set virtual equivalent.
Okay, so now but trap and immediate alarm was not always efficient, and especially for the older x86 system. Some instructions were sensitive but did not always trap clean. That is a very binary transmission function.
Yeah, you are correct. Binary translation allows the hypervisor to rewrite or add the portion of the base code dynamically so that the problematic instruction could be safely redirected to somewhere else, which helps to improve the compatibility, but it also reduces the overhead. The hardware vendor step in and hardware assisted virtualization can solve that problem, I think.
Yeah, exactly. Intel introduced the VTX and the AMD introducing the EMD. These hardware extensions made a secure virtualization much easier and much faster by adding support for the running case in a special mode and for the handling privileges operating more clean. With hardware support, the CPU can distinguish between guest mode and hypervisor mode more naturally.
So in modern virtualization, I think CPU implementation usually work like this. We have to execute most directly on the physical CPU, while the hypervisor intercept only the operations that truly needs full control, such as sensitive system calls, previous state changes, or scheduling decisions. All are handled by the CPU virtualization.
There is also another important idea, is the context switching. Every time the hypervisor switches from one VM machine to another, it must save the restored CPU state, registers, flags, instruction pointers, and also the control data. So that is why efficient scheduling matters. Too many virtual machines which can degrade the performance of our.
Yeah, I agree that it can reduce the switching the VM can reduce the performance and make the virtual CPU feels real. So the hypervisor present each VM with the set of virtual hardware features like virtual registers, interrupts, timers, sometimes multiple vCPUs for multiprocessing.
Okay, got it. So the instance of CPU virtualization in this, the hypervisor multiplexes the physical CPUs across many gates by preserving the illusion that each gate has a dedicated processing power. So our next point in and next question is very important. That is the memory virtualization. So what is the about the idea about memory virtualization?
Yeah, coming to memory virtualization, I think it is very big industry compared to CPU one. So, which is arguably trickier as well compared to other virtualization as well. Memory virtualization ensures that each virtual machine believes it has its own piece of memory and memory space, even though the physical RAM is shared among many VMs. So they don't feel that they are will be shared to another and other kind of discomforts.
This introduces a layered translation problem. In a normal machine, a program uses virtual addresses that maps to physical memory. In virtualization machine, there is often an extra layer involved. The guest OS thinks in terms of the guest physical memory, but hypervisor ultimately controls access to the real physical memory.
Yeah, that means the memory is often translated into two stages. First is the OS translates the virtual addresses to the base physical addresses. Then hypervisor or software translate that into the base practical physical addresses to a machine physical addresses. I think.
So earlier virtualization system used the shadow pages tables to handle this. The hypervisor would maintain the separate set of page tables that mirror the guest mapping but point to the actual physical memory. So this work, but it is expensive to maintain the because every guest page table update would trigger hypervisor environment.
Yeah, that would become the major challenge for performance. So again, hardware support improves the things. Modern processors supports nested translation mechanism such as extended page table on Intel and nested page table NPT or AMD. This allows the address translation to happen more efficiently in hardware and reducing the hypervisor workload.
Yeah, correct. Means simple terms, the hardware gives to a CPU top both the guest page tables and also hypervisor managed tables. So memory transfer becomes much faster than software only methods.
Yeah, now let's talk about one of the most important rules of virtualization is isolation. Each VM should holds the contiguous chunk of memory. But in reality, hypervisor may place those pages across the multiple physical RAM. The guest should never be able to access the another VM's memory. So that helps us to make isolation better and avoid the memory corruption as well and avoid resolution.
Yeah, exactly, that's right. So that isolation is forced by page tables, permissions, and the hypervisor control over the allocation. Means the another concept is here is the memory over the memory. This is the different degrees. So the system may allocate more virtual memory across all the virtual machines than the amount of actual RAM available. Assuming not every virtual machine will unspeak or maximum at the same time. So what is the opinion of you?
Yeah, that can increase the utilization, but it is handled carefully. If too many VMs demand the memory simultaneously, system can start swapping and which can hurt performance as well over the time.
Correct. So to manage this, hypervisor often use techniques like ballooning and balloon drive the inside the disk OS can they inflict or deflect the recreate and or the release the memory damage. So the hypervisor asks the guest to give some memory when under the pressure of the and return if the available.
Yeah, there is also caching and cache sharing. So that can help to reduce the overhead. And in some environment, identical memory pages across the VM can be duplicated. So that can avoid the memory options very much. Also, it has the security and design trade-off, which we have taken in mind.
And it's not a forget use pages. Using the layer memory pages can reduce the translate overhead and also improve the performance of our workload, especially database and high performance computing.
Okay. So, memory expression is really about the three things: address translation, protection, efficient allocation. An hypervisor must make memory look private, flexible, and fast.
So this was the next and very important topic is the input-output virtualization. There are the very large amount of multiple people are saying the input-output virtualization. There are the very complex topic. So what is the idea about this topic? Now we come to the input-output virtualization, and this is the where thing is specially interesting because drives are not a simple CPU and the
Yeah, the challenge is that a single physical device often needs to serve many VMs simultaneously, but each VM should think it has its own disk computer or network path. So there are several ways to achieve that.
So the first approach is the device configuration. The hypervisor pretends to be a standard piece of the hardware. For example, a virtual ID controller or virtual network card. The guest OS use the device as if they were real, while the hypervisor translates those requests into actual operations on physical devices. What is your opinion on this topic?
The method in which the compatibility of the base storage does not need the special drivers, but can store because every I/O request may pass through the hypervisor and extra overhead can occur.
Okay. So the need of the rise of paravirtualization device. Here the guest uses the specially drive designed to work more directly to the hypervisor. A common example of the virtualization the KVM based environment. Instead of presenting to the old hardware, the system uses a more efficient interface optimized for the virtualization.
Yeah, that significantly improves the performance because the baseline hypervisor cooperate here together instead of pretending that everything is invisible. Another major method is direct device assignment. Sometimes it's for PCI fast food.
Can you please explain me the poster content shortly?
So you can see here there are 5 levels. So first one is instruction, which puts architecture architecture. Second one is hardware abstraction. Third one is OS level. Fourth one is library base code. Fifth one is the application isolation. So we are using from level 5 in a computer, but under the hood, each level is giving task to some their own level. You know, so these two levels are low level, and we can say these are the software defined levels 3, 4, 5. So in fifth one, we everyone know that virtualize only app and dependencies to eliminate the version conflict and the day level. And coming to the level 4, it intercept the system calls to run the app across a different OS environment, for example, Y or WSL. So level 3 can also come into software, which is OS level containerization. There is multiple isolation user space instance, say single kernel for millisecond startup and high efficiency. For example, we can say as Docker for Linux containers.
Okay, so we move to the next question now. So there is the SRIOT, the single root input output voltage. This is the very powerful technique where one physical device can expose the multiple virtual functions, each of the which can be assigned to a different virtual machine.
So let's also talk about the interrupts. Every device modified the CPU using the interruptions, but the virtualization those interrupts must be virtualized too. Hypervisor may inject virtual interruptions into the cache, so it believes its own device has completed an operation.
Okay. And it is important because network package and the disk completion needs to go immediately and the current from the guest perspective. So modern systems also use the techniques like virtualization, DMA mapping and multi-queue device to the reduce the overhead and improve the throughput. So what is the idea?
So IO virtualization is about presenting and delivering the device model while balancing compatibility and performance and control.
So our next question and last question of the podcast, that is the how CPU, memory and how input output work together and how it is the efficient. Means the now that we have the examined them separately, it is the work see how they are interconnected. Our solution is not really isolated by one layer alone. It's protected by the all multiple layers, like the 3 layers I can say that it is the CPU virtualization, memory virtualization, input output virtualization. So what is your opinion on it?
Yeah, and if one of those layers becomes inefficient, the entire game experience can become can suffer. So for example, if CPU utilization is fine, but when translation is slow, application feels like very sluggish and slow. If the memory is efficient but I/O is emulated poorly, the database VM could still bottleneck by this excess.
Right. And that is why hypervisor design is such a balanced act. The system must choose between the capacity and the performance. Means sometimes emulation is the better because it supports the nearly any guest OS. Sometimes the parallelization is the better because it is the fast. Sometimes direct assignment to the best because latency is the critical.
Yeah, and it is also why different workloads choose the different virtualization strategies. So, lightweight web server VM isolated emulsion, a storage mode GPU intensive machine will probably demand the fast through or para virtualization drivers. And we can see here performance overhead and isolation strength. So ISO level has the high performance and isolation is high. The hardware has the low performance but isolation is very high. OS has minimal performance overhead, but isolation is moderate.
OS is very minimal. What is the reason about that?
I think the OS just help us to coordinate the multiple processes and manage them and monitor them how they are working and not doing the shady activities. So OS just keep the track and manage the things. I think that.
So this is the 5 years of our college.
Yeah, we can see that. So there are many enterprise foundation here. or by bare metal, which can be used in today's cloud. Hypervisors come here on second segment, like VMware, HCI, and Microsoft Hyper-V that are provided. And voice of containers project can be also we can get through services and API we can use for of other services like calendar or weather or any news API. Application we know that we can download it really easily.
It's a wrap up it is a clearly at the CPU level virtualization. The silent processing times along with what you using the CPU and scheduling the NAP and hardware like ready and electricity.
Together, these three virtualization layers make virtualization possible in practical, scalable way. They allow the cloud providers, data centers, and development teams to run many isolated system on single physical machine. And it is a reality of implementation, real world virtualization. It is not just about creating virtual machine, but making the hardware efficient, secure, flexible enough to behave like many.
And now hopefully I another mechanism feels much cleaner.
Yeah. Now, look, that's all for today's episode. Thank you for listening, and we shall see you next time.
Okay.